Autoregressive distributed lag ARDL models are standard least squares regressions which include lags of both the dependent variable and independent variables as regressors. Although ARDL models have been used in econometrics for many decades, they have experienced renewed popularity of late as a method of explaining dynamic, long-run, and cointegrating relationships between variables. EViews offers a simple, easy-to-use ARDL estimation engine that automatically detects the appropriate number of lags of each variable to include in the estimation, and provides post-estimation tools to view the long-run or cointegrating relationship form of the estimation and perform bounds testing. To demonstrate, we will use data made available by William Green in his textbook Econometric Analysis. The data consists of a number of quarterly US macroeconomic variables dating from 1950 to 2000. Following one of the ARDL examples in his book, we will examine the relationship between the log of real consumption and the log of real GDP. Real consumption data is held in the series Real Cons. Real GDP is held in the series Real GDP. If we look at a graph of real cons, we can see that it is, as we would expect, upward trending. Similarly, real GDP is also upward trending. To estimate an ARDL model, we click on Quick, Estimate Equation, and then use the method drop-down to select ARDL. In the dynamic specification box, we enter the name of our dependent variable, the log of real consumption, followed by the name of the dynamic regressor, the log of real GDP. We'll instruct EViews to select the optimal number of lags of each of these variables by using the automatic selection button. And then for both the dependent variable and the regressor, we set the maximum of lags to consider to 8. Following Green's example, we'll use a constant and a set of quarterly dummy variables as fixed regressors. We can use EViews' @expand function to generate the entire set of dummy variables. Switching to the Option tab allows us to choose the criteria used for model selection. We'll select the Han and Quinn criteria. Clicking OK produces the estimation results. The top part of the estimation output shows summary information about the estimation, including the name of the dependent variable, the date and time of estimation, the number of included observations, the number of different models evaluated, and perhaps most importantly, the final selected model, in this case an ARDL 5.1 model. The middle part shows the individual coefficient estimates for the selected model. We can see that each of the regressors are statistically significant apart from the quarterly dummy variables. The bottom part displays summary statistics based on the final information, including the R-squared, which is very high for our estimation, and the information criteria. To judge how strongly the selected 5.1 model is preferred over other models, we click on View, Model Selection Summary, Criteria Graph. Here we can see the Han and Quinn criteria for each of the top 20 different ARDL models. A lower value is better. The ARDL 5.1 model appears to be strongly preferred to the other models. It's also notable that the top 3 models all include 5 lags of the dependent variable. We can view the cointegrating and long-run relationship defined by these ARDL estimates by clicking on View, Coefficient Diagnostics, Cointegrating and Long-Run Form. In our case, we can see from the long-run coefficient estimate of the log of real GDP that the effect of GDP on consumption has essentially no long-term lagged effects. The coefficient is very close to 1. To further test the existence of a long-run relationship between real consumption and real GDP, we can perform the bounds test of Pesseran, Shin and Smith by clicking on View Coefficient Diagnostics Bounds Test. In our case, the F-statistic of the bounds test is below each of the reported critical values, thus we fail to reject the null hypothesis that there is no long-run relationship.